In this video, we will discuss the usage of an alternative Python runtime called PyPy. So PyPy is another project which provides a faster runtime, a reasonably fast runtime for Python, which you can use as a drop-in replacement for the official Python language runtime. So to discuss more about that, if you have been using Python officially, uh, the runtime that you will download and use is generally from this project, which is the official Python project. Uh, the runtime that you get here when you go to downloads is also called as the official Python runtime, also known as CPython. Even if you use Anaconda distribution of Python, or if you have Python installed by default on many of your Linux distributions, the version and the implementation that you see comes from the python.org or the Python Software Foundation project. This official runtime is implemented in C over the years, right from the beginning. And this implementation uses a bytecode interpreter version of Python, which also means that every statement that you write, the Python source code, it's actually converted to bytecode first. And then the bytecode is interpreted statement by statement by the Python runtime. This has some performance penalty, which I discussed. We saw that in the performance that makes it quite slower. Well, there used to be a lot of alternative Python runtimes, other alternate runtimes that existed over the years, and one that really is popular in the last 10 years or so, more than 10 years now, is PyPy. Now, PyPy project originates from another project called RPython, which you can get access to by going to RPython website. If you just search for rpython.org, you'll have access to it. And this PyPy has eclipsed this particular project. Originally, RPython used to be a project for adding static typing to the existing Python project as such. You just search for RPython and you click on this link, which is here. Um, it's sort of in the documentation, right? So they say the RPython is a translation and support framework for producing implementations of dynamic languages, emphasizing clean separation of language specification and implementation aspects. Yeah, looks vague, but if you look at your code that you write in RPython, it adds some newer syntaxes for static type declarations, and this allows code to be more optimally compiled and executed. So the problem here, though, with RPython is that you need to refactor your entire code, right, to make introduce static typing to benefit from its performance. What a community of folks did, community of people, programmers did was they re-implemented Python following Python specifications using RPython. And when they did that, they also added a lot of interesting features like support for just-in-time compiler, which is a very important feature that makes Python code run very fast, mostly comparable to languages like Java, I would say, closer to it. And it also adds better handling of multi-threading. So if you're looking at concurrency features, they introduce something called stackless implementation of threads. And they also have fully compliant with existing Python syntax, which means that you can have your pure Python program without any changes. You can just change the runtime to PyPy and you could see drastic improvement in performance, which I'm going to demonstrate right here. So you can download PyPy by just going to pypy.org, as you can see here. And I'm not sure if it's supported on all platforms. That's one challenge. I think recently they added support for Windows, I guess, but for a long time it was only available on Linux and macOS. I think the Windows implementation, I think if we just go to downloads, we can find that out right here on what all platforms support it. Yeah, I think they have supported Windows now. The newer versions do support Windows. You can see that right here. So Windows, Mac, Linux for ARM64, or Linux for x86. So all these variants exist. If you're using a Linux environment like me, I think if you use your distributions package manager on all the mainstream Linux distributions, they bundle PyPy. So on my Raspberry Pi board, I'm using Debian, and you can install PyPy by just using an apt install PyPy 3. So PyPy has two versions, PyPy for Python 2 2.x version and PyPy 3 that that's compliant with the Python 3.x syntax, right? So I have installed PyPy 3 on my setup on my Raspberry Pi board, which I'm going to demonstrate by running it. So in order to try this out, what we'll do is I've already installed PyPy 3 just in case. You want to install it on Debian, Ubuntu, and all these Debian based distributions, including Ubuntu and Mint and others, you could use sudo apt install PyPy3. Of course, in some distributions, it might just be called PyPy instead of PyPy3. Like in Arch Linux, I think it's simply PyPy, right? It'll always give you the Python 3 version of it. Now, once you install PyPy, you can also launch the Python runtime, the PyPy implementation of it, just by typing PyPy. In my machine, I need to run PyPy 3 though, because there could be two versions, PyPy 2 and PyPy 3. So you get the Python 3 implementation. The one that is shipped with Ubuntu, in Debian, the Debian bookworm on the Raspberry Pi board, is compliant with Python 3.9. That means if you're using newer syntax of Python 3.10, hopefully the match construct might not work on this version. But if you get the latest version of PyPy, which I hope I have installed in my Arch base setup, which is Garuda Linux, let me try it here. Oh, this is PyPy 2. As you can see, it shows Python 2.7.18. Let me exit this and try PyPy 3 here. Here too. The latest version of PyPy 3 at the time of recording is compliant with Python 3.10. We'll discuss about these as limitations for a while. But first thing, you can try all the things that you do with Python in this REPL. You can see a 4 greater than prompt here. It's very interesting, rather than 3 greater than prompt for the shell by default. Now what I'll do is I will try running the prime number generator that we had written in Python using PyPy, just to show you that the difference, the comparison. This file which I have called primes.py, the same program that I demonstrated in lecture 1 and also compared in all the previous lectures in the earlier section. Just in case you want to see how that program looks like, I'm just going to open up this primes.py. You can see that right here. Yeah, by the way, the cat command I'm using is an alias to bat command on my Linux setup. So it gives you a pager. Anyway, so this code is the same code, no changes at all. What I used in lecture 1. And in fact, when I run this program using the official Python runtime, using Python primes.py, as you can see, it's going to take about 13 point odd seconds. Yeah, it's quite slow, right? And it's completing. Yeah, 13.2 seconds this time. All I'm going to do is just run PyPy3 and the same program instead. You can see the difference. What took about 13.2, 13.3 around that time frame, that many seconds, now the same program was able to run and give you a performance where it's able to generate the first 100,000 prime numbers in 2.53 seconds, which is a significant improvement. In fact, if you look at the website, the official stats tell you that PyPy is at least 4.4 times faster. I'm not sure how they got this math, but I think it's an average. On average, it's like 4.4 times faster than CPython 3.7, right? That's what you see. But we can see in our case, for our code, it is actually much faster than 4.4 times. I think it's more than 6 times or 7 times faster, right? So that's what you see here. So this is what PyPy is all about. You don't have to make any changes to your code. Just you have your Python program. You just want to improve the performance of your existing Python code without any refactoring, any changes. Just change the runtime to PyPy and it works. But is this a silver bullet? That is, can I just go over the board and change everything to PyPy? Now I should talk about certain limitations. Limitation number 1 is the version compatibility. PyPy is not fully compatible with the latest versions of Python that get released because it's a different project and the team of developers working on this project do take some time to adapt to new features coming out with new releases of Python. So as you can see on the website right now, they currently support Python 3.10 and Python 2 is also still being maintained for legacy reasons. So Python 2.7 and Python 3.10. However, if you look at the official Python that is there, the latest version as of the time of recording, I think if you look at the version, where do I get that? I think it's here. You go to downloads, 3.13 is released, right? 3.13 is a latest stable version as of 2024. But you can see that PyPy is trailing like 2 or three minor versions behind. Yeah, they generally trail behind by 2 to 3 years, right? That's one thing. But as long as you're not using latest, greatest features of Python, I think this should not be a big problem. Limitation number two, this can be a big one. It can also be a showstopper in many use cases. You can use PyPy when you have a pure Python program. What I mean by telling pure Python program is, for example, the prime number generator is a pure Python code. And what are the kinds of Python code exist if it's not pure? Well, if you have a Python program that uses some libraries or frameworks that are based out of C extensions or any other language extensions these days, like Rust, C, C++, PyPy might not be able to run that, right? It might actually crash. It's not very compatible with C extensions. So if you want to write, if you're building a framework on your own, which are based on C or C++ extensions, the suggestion is to use CFFI for building extensions. This is PyPy compatible. Unfortunately, there are way too many C extension libraries available right now that do not use CFFI. CFFI stands for C Foreign Functions Interface. This is for developers who build Python libraries like performance critical or low level libraries that they want to write in C and make sure that you can access it via Python. That's what CFFI provides, and PyPy is compatible with this. But the official way of doing it, the standard way of doing it, is not using CFFI, but by using the Python standard libraries, extension module. For example, you go to the Python documentation, and if you just go to the Python docs here, you do have a section called extending and embedding, right? So when you click on this, it shows you how you can extend your Python code using C program. They show you how you can do that by using extending Python with C or C++. They give you a small example, a simple hello world example that you see here. This is the official C extension mechanism that is provided by CPython. And this is not compatible with PyPy. So if you have written C programs like these and build them as .so or the library files that you can load as module in Python, they may not work with PyPy. Places where I found issues with it in the early days, I've not tried out in the recent years, but I remember it was a showstopper, at least the last time I tried out in sometime in 2015, 2016 timeframe, is Parallel SSH and Paramiko. So these frameworks, which are used for SSH automation, are heavily dependent on C extension libraries for your cryptographic algorithms and so on. So that is a big problem. It becomes a showstopper there. And there are many such kind of frameworks that are available. In early days, even NumPy and SkyPy had issues, but the good news is that PyPy claims to now support SkyPy and NumPy modules. I have not personally tested it, but I would be a little careful in using them. So as long as you're not completely built your module using CFFI, this can be a big problem, right? So CFFI is one thing that you use, and if you're building C++ kind of programs and you want to use it as Python extensions, there's another project called CPPYY. Okay, it's a C++ equivalent of CFFI library, right? For extending your Python code with C++ code as such. So as long as you're using these two projects for building extension libraries, it'll work with PyPy. Otherwise, it may not work. But where you can safely use PyPy is on web frameworks like Flask, Django project. So all of these kind of web frameworks perform much, much better when you run them on PyPy, right? As long as you don't use any third-party libraries that still depend on C extensions, right? That's something to keep in mind. Or any kind of pure Python algorithms. You build some kind of a complex algorithm in Python and you believe it's computationally more intensive and you want to improve performance, you can just change the runtime to PyPy and it does the job quite well. So the official docs do mention that you can use PyPy for speeding up NumPy and SkyPy based projects, but I would be a little skeptical at this stage, even now, because I have not really tested it to the corner case scenarios. But I think for basic use cases, that should work, right? That's what you should know about PyPy module as such. So when it comes to an alternative runtime that gives you the least intrusive way of improving performance in Python, PyPy would rank number one. because I did not have to change anything in my code. Just change the runtime and it works, right? In the next video, I will talk about other alternative ways to improve performance of Python, which requires a little bit of modification and tweaking in your code in order to make things work, right? We'll look into that in the next video. Thank you very much. So meet you in the next one.